Which chapter were you got?
Others are not coming on. Okay, well, let's try.
Which chapter you have got?
I see. But this one, chapter number 2, we have already completed.
Atom or molecule?
Oh, we also is over.
Yes.
2 is over, 3 is also over. How to write down the formulas and all that I have taught you. Exercises, there are 1 and 2. I said I will do it in the class. We'll complete that and then of course we will go to the next one. 36. This is the
6 months. You
36. This is the name.
exercise.
Exercise, correct? Exercise, you take the first and the second one. I'll do those 2 tasks for you and then we will go. Question number? First one.
And third, fourth, fifth, and sixth is there.
Okay, done.
This is this fourth. And this was done.
Yeah. You have done now?
Which?
4, 5, 6. I've given it to you for homework. Check it out, give me a book. Just give me a book. I mean, I'll just check out 4, 5, and 6. We have done it for homework. It's in 3.
You gave it as homework.
Yes, ma'am, you gave it as homework. 4, 5, and 6, ma'am. I have completed.
4, 5, and 6 I have given it to you as homework. I'll check out your answers also. Have you done it? No. See, that's what happens. People did not come for open day.
I came.
You have seen one.
I came to this class.
I was sitting there. You stood right down.
Ma'am, my mom and went to hospital.
Okay, so let's do the first one. Okay. 0.24 grams sampling of compound oxygenol and boron was found to be by analysis to contain 0.96 of boron and 0.114 grams of oxygen. Are you all listening? Important reading now. Pay attention to this. I'm reading the first question here. You have the question. Okay. Calculate the percentage composition of the compound by weight. Now, I want you to recall and remember the reference things to laws. What were the 2 laws? Okay. So, if you look at the previous page, that is the very first page, laws of chemical combination. You want to see that? Laws of chemical combination. Okay. There are 2 of them. What are those 2 laws? The first law
is
says
here and
law of. No, I'm not talking about the scientist. I'm talking about the law. The first law is the law of conservation of mass. So here we have law of
Conservation of mass.
conservation of mass. Okay, that is one law. What does it tell us? Do you remember what this is? Conservation of mass means what? Mass is getting conserved. Okay, whether you are talking, let us say for example, if A is combining with B and it forms C and D, different compounds are formed because of a chemical reaction, but the mass of this mass is equal to the mass of the product. You can understand?
Yes.
This is the mass of a reactant and this is the mass of the product. Okay, so this is the law of conservation of mass. Have you followed? Did you understand what it is? Write it down in your notebook. Write it down this way so that you understand. It says that I have already given it to you. In the very first time, remember we have done, we already done. So it's just a revision part so that you know what we want. Okay, mass can neither be created nor destroyed. Why? Because I know it up in this right, mass of the reactant is equal to the mass of the product. Total mass. I'm talking about the total mass of the product. And the second one is the law of constant
Glucose.
yes.
Law of chemical combination. Law of chemical combination.
See here. See here. Law of chemical combination, there are two laws. This is the first law, this is the second law. Okay. Both the laws together is called as finish again. There, what have you written? What is this law called? Write about the okay, now look at the second law, law of constant proportion. What does it mean? Constant proportion. What is the proportion?
Proportionality is constant.
Yes. Okay, if you are talking about the proportion of any particular compound, that proportion of the different elements is only constant depending upon whatever method that you have already prepared. Did you understand? For example, if I'm talking about, let us say, water, what does it tell us? That two parts of hydrogen become one now. But with respect to mass, it's how much? We're talking about 2:16. Hydrogen is 1. So 1 plus 1 and this is 16. So therefore it is always combining in a mixture of 1:8. So that is your constant proportion. Now look at the question. Did you write it down? What is it? So what does it tell us? Write down the statement. In a chemical substance. I'm talking about the second law. Write it down. In a chemical substance. Second one. The elements are always present in definite proportion in a chemical substance. The elements are always present in definite proportion by mass. By mass. This one is great. Okay. Now we go back to this exercise and we discuss about the question number 1. See what you understand. What do you understand, friend? Why don't you get your NCERT textbook?
The pages actually are not binded or
And because you know time and again that I'll be referring to this textbook itself. Look at the very first one. Okay, shall I rub it out? Shall I erase this? And now you have to decide and tell me whether we are talking about the law of constant proportion or it is the conservation of mass. What is the compound that they have given? Read question number 1 and read it. Veera Kasana, what have you read? Yeah, so that's okay.
0.24 gram
Of what is given? Point
compound.
compound of what?
Oxygen and boron.
Yes, correct. So you have boron and oxygen. Okay, so it is boron oxide. Do you understand? So boron oxide.
If boron was found by analysis.
And see what is the amount? What is the
0.096.
So what is this? This is 0. How much is the mass which they have given? 0.24 grams. Right? Was found by analysis to contain 0.096 of boron. So out of this, we want to find out how much is boron and how much is oxygen. Correct? So I just put it as boron and oxygen is boron oxide. And if you find out what is the okay, so boron was found, how much is it? What is found? Boron is found how much? Tell me the interesting number, 0.096 grams of boron, and oxygen is how much? 1.144 grams of oxygen was found. Right? Calculate the percentage composition of the compound by weight. So what do we have to find? We have to find the percentage composition. How will you do this? How will you do it? Percentage, how will you find out percentage?
4 upon 100 into 24.
Whatever it is. Now, for example, in your, let us say in your test or whatever it is, somebody out of 30 marks. Okay, let us say the person is taking 26 marks. How will you calculate the percentages?
100.
Out of 30 marks, you are getting 26 marks. Therefore, out of 100 marks, we want to find out how much it is. So, what will you do? Cross multiply. So, it is 26 times 100 by whatever is your total. The same concept we have to find out here. Okay. This is the total amount of boron oxide. In boron oxide, you have got so much of boron. Therefore, in 100 grams, how much is it? So come on, calculate this. Okay, to calculate the percentage composition. So you will write in 0.24 boron oxide. Okay, 0.096 grams of boron is present. Therefore, in 100 grams of boron oxide, you are finding out X. So what we need to cross multiply? 0.096 into 100 divided by 0.24. Shift the decimals.
96 upon 24.
96 upon 24.
96, what about this 0?
So this
See here there are two zeros.
0.096.
1, 2, you will shift 1 and 2.
9.6 upon
9.6.
9.6 out of 24 into 100.
9.6 by 21.
So it is equal to 9.6 into 100. So even here also you can shift it. Okay, this one more you can shift it into 10 to 960. Okay, so that is 960 divided by 24. 960 divided by 24. Come on, do it. Correct. 3 times, 4 times. How many times? It's a whole number if you want, it's not even a fraction.
40%?
Does it go 4 times? See that?
Yeah.
Correct, no? See, 24. 24, 4 times is 96. Correct, no? You got it? What I'm saying? How much is 24? 4 24, 4 are 16, 1
Okay.
carry, and this side is 6, so you cancel it out, it is 40%. So your answer is 40%. 40% of what you find out is?
Oxygen.
Of
Boron.
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 Okay, so boron is present as 40%.
Boron.
Now what is the other part of the question?
Oxygen.
Calculate the percentage composition of the
60%.
compound by weight. Yes. So obviously the other part of it has to be 60. So if this is 40%, we will have this as 60%.
So it's 22 divided by 44.
You understand? See, you can also calculate. You can also calculate. So the same way we have to do is only thing is 0.144 upon 0.96.
It will just become 144, right?
Shift, yes, 144.
Upon 24, which is
96. Did you get it? So calculating percentage composition is very easy. all that we have to say is what is the given weight divided by the total weight into 5. Right? Okay, the next question, question number 2. When 3 grams of carbon is burned in 8 grams of oxygen. So first of all, let's write down what is given to us. What are they given? What are the 2 elements that we have taken? Carbon and
Oxygen.
oxygen. So we have got carbon, we have got oxygen. How many grams of carbon? 3
3.0.
grams. 3 grams of carbon. And how many grams of oxygen?
8.
8 grams.
And carbon dioxide.
Okay.
Carbon
Okay.
dioxide.
Yes. What mass of carbon dioxide will be found? So can you give me the equation here? What is the equation here?
11.
Carbon plus oxygen gives carbon dioxide.
11.
Okay.
11.
So wait. So that is the information which is given. And how many grams of carbon dioxide is produced?
11 grams.
11.
So question is
Ma'am, 11 grams.
11 grams. Did you understand what I'm saying? So carbon dioxide produces 11 grams. Okay. Now next part. What mass of carbon dioxide will be formed when 3 grams of carbon? Now this is what is given to us. But we are asking you if 3 grams of carbon is burned in 50 grams of oxygen. So oxygen, they want to take it as 50 grams. And they're asking you how many grams of carbon dioxide is being burned. Which law of chemical combination will govern your answer? Tell me. I will have all the information on the board.
Law of constant proportionality.
Okay?
Law of constant proportion.
Proposed by
And because
Three
the
raised to
proportion
eight
won't
raised to
change even though the proportion won't change even though the mass changes for the
Yes,
Good.
yes,
Tell me something. Yes, you're right. Express it properly. What else? See, now you know that 3 grams of carbon requires only 8 grams in order to produce 11 grams. Okay? Whether you produce carbon dioxide by whatever method, the proportion of carbon to oxygen will not change. Now we have taken so much more oxygen. Will it combine with more oxygen to produce something else? No. Okay? It still requires only 8 grams. 3 grams will only combine with 8 grams. And what else is remaining now? Out of 15, if only 8 grams is required, how much is still remaining? Yes, so 42 grams of oxygen is not utilized. Did you understand? It is not used. So much is not used. And 3 grams, only 8 grams. 3 grams of carbon will react only with 8 grams of oxygen to give you carbon dioxide. How much of carbon dioxide? How much of carbon dioxide?
11.
Only 11 grams. So which law does it tell us? Law of constant proportion. Come on, get it up. 3 grams of carbon requires only 8 grams of oxygen to form 11 grams of 11 grams of what? Carbon dioxide. Abhishek, did you write that? Right? So how much is remaining?
12 grams.
Right?
Good.
How much is remaining? Yes.
What we do?
Okay, out of 50,
What we
do you
do?
have? I'm asking you to be. What were you doing?
Out of
Statement I wrote it down, I wrote it in the law. Still properties.
Constant proportion. Right or not? Okay. So out of 50, 42 grams are not utilized or not used. Out of 50 grams, 42 grams are not used. Therefore, It confirms the law of constant proportion. Okay, now quickly we will go through the answers of homework because you people have not done, no? Nobody has done, right? Not done? Done? You have done?
So, Mama did.
Oh.
Who is it?
Mama did the switch one.
Names, you have written down names. Chalo, let's see question number 4.
And 3, yeah.
3 you have already finished. 4 also we have finished. You have not done. What is polyatomic? Manmay? What is polyatomic ion? Right, look at the question. I'm looking at the question. What is polyatomic ion? What do you understand as polyatomic?
And which are two atoms.
Like, for example, give me one example.
And which are two atoms.
Yes, correct. More than 2.
More than 2.
One.
Yes. So give me one example. What are polyatomic? Hydrogen is only one. What is it?
Calcium oxide.
Ion. They're talking about ion. Understand?
Ammonium hydroxide.
No, ammonium hydroxide is a compound.
Hydrogen carbonate.
Hydrogen carbon. Okay. So if I'm talking about, let us say, polyatomic. Write down. All of you write down. This is something that is, I am not liking it at all. When I give you something for homework, it needs to be done. Right? Polyatomic. Okay, something that has got more than 2 elements. For example, bicarbonate or hydrogen carbonate. If you understand this, okay. For example, sulfate. Okay, hydroxide. All these are examples of polyatomic. Give me one, Abhishek, give me one positive. That you can. Which is which is polyatomic.
Ammonium chloride.
Ammonium, that's all. Now, ammonium chloride is an entire compound. Okay, so we can just say it is ammonium. Write down. Come on, quickly. This is question number 3. Sorry. Examples of polyatomic ions.
Only 2 or more.
Which one?
One polyatomic.
What are poly?
Elements. See, you see that these are all elements, no? 2 elements or even more.
They have
Here it
2
is
or more
See, this
elements.
is 2 or more. The rest of them. Okay. Now, starting from here. So, Penny, what is the chemical formula for magnesium chloride? Magnesium chloride. By now you should know. By heart.
MgCl.
MgCl2. MgCl2. Magnesium chloride. Come on, write down. Write down.
HCO3.
Next one, calcium oxide. Calcium oxide. What is it?
Calcium oxide. CaCO.
CaO. Calcium oxide.
CaO.
Next one. Project number 10. Copper nitrate.
CuNO3.
CuNO3 bracket 2.
Copper nitrate.
Bracket 2.
Okay, because copper is having valency 2. See, there are 2 valencies for copper. Copper 1 and copper 2. 1 and 2. Okay, so here we are using the second 2 valency. Copper nitrate. What is the next one?
Ammonium chloride.
Is it ammonium? Read properly.
Aluminium chloride.
Be careful, huh? Many children make this mistake.
Aluminium.
Aluminium and ammonium, both of them are very, it sounds also very similar. So what is it given there? Aluminium.
AlCN3.
Correct.
AlCN3.
Yes, AlCN3, aluminium chloride. Last one. What is the last one?
Calcium carbonate.
Calcium carbonate. CaCl.
Ca3, CO,
CaCl3.
Ca3, CO.
Write down. Everybody write down and tell me what is the answer. Calcium carbonate. Come on, quickly.
I was not looking.
Yeah.
Next class I'm going to give you a test.
CaSO3. Ma'am, CaSO3 bracket HCO3.
Why HCO3? Carbonate, not
Ca2,
bicarbonate.
CO3 bracket 2.
अच्छा हाँ
Calcium carbonate.
हाँ.
Carbonate is also 2. This is also 2. This is 2. This is 2.
Cancel.
This will get
CaCO3.
cancelled. When you cross multiply, this will get
CaCO3.
cancelled. So answer is CaCO3. That's all.
अच्छा.
Next one. Question number 5. Who can do that?
ma'am, quick line is calcium and oxide.
Calcium oxide.
Calcium oxide. And ma'am, hydrogen or bromide is hydrogen plus bromine.
Give the names of elements, okay?
And baking powder is sodium plus hydrogen plus carbon plus O2.
Okay, oxygen. Oxygen you have to say, not O2. Oxygen. Then
And now potassium sulfate is potassium plus sulfur plus oxygen.
if you know what is the formula, you can identify what are the various elements which are
Calculate the molar mass.
Okay. Now, for example, calcium oxide. For example, you have got which like so calcium oxide. So elements which are present here, carbonate C. You have calcium, you have got oxygen. Okay, so for each one, you are going to write down the formula and then identify. Put a tick mark here. All that not put a tick mark. The last one also we have done. Calculate the molar mass of the following substance.
Section.
Ethyl. Okay. So C2H2. You remember what is a molar mass? How do we find it out? C2H2. What we should do? We should see the atomic masses and add it up together.
Atomic mass of HN.
Of carbon, how much?
24.
12. 12 into 2. Because there are 2. So 12 times 2. And then we add it to hydrogen. Hydrogen is 1. And there are 2 atoms. So
26.
this is 24 plus 2. That is equal to 26.
Oxygen
Okay. So 26 is what? What should you write?
You are a
You.
You should write U. So this is your atomic mass.
And we said A also.
AMU work, but since they have given as U in the textbook, so we stick to U. It is called as unified atomic mass. Okay, now we learn that this unified atomic mass. Come on, guys, if you finish this question before we go on. Sulfur molecule, S8. Refer to the table. Which table will you refer to? The one with the masses.
Sulfur molecule. That's it.
Sulfur molecule has got S8.
Sulfur molecule.
S8. How much is sulfur? For each atom, how much is it?
But sulfur is.
Which table?
And sulfur is.
This is iron beta. This is what iron. So it's a simple
And
element.
sulfur is.
26 U.
See, this is what you should have. See, atomic masses are there. See, the sulfur, how much it is. Sulfur here, 32. So 32 is what? What did I put up?
And sulfur is 32.
How much is 32 into 8? Come on, tell me.
26 U.
Huh?
256.
Okay, next one. Phosphorus molecule.
24 U.
P4. Phosphorus is 31. 31 and
24
24.
U.
I'm going to do the next one. Phosphorus.
24.
You have to do it in your notebook. It's given it. They've already given you here. Atomic mass is 31. In the question.
31
Into how much? P4 is there.
4.
31 into 4. 31 into 4. Kaushik and Abhishek,
124.
I want your answers in the notebook.
Yes.
It has to be done in the notebook. Because afterwards, after another month, you will say, no, we have completely forgotten. Let it be there in the notebook. Come on, do it.
Hydrochloric acid. It's
C means like oxygen.
Ozone.
Ozone layer.
Hydrochloric acid, how much is it?
Skin.
Ahmed.
Phosphorus molecule.
Hydrochloric acid.
Yes, hydrochloric acid. Hydrogen is 1. Fluorine is 35.5.
36.5.
Come on, write it down in your notebook.
Phosphorus molecule.
Correct. 36.5. Write it in your notebook. HCl is equal to 36.5.
Phosphorus.
Last one is nitric acid. Do it correctly. HNO3. Sorry.
I can't remember.
What is O3?
O3 itself is ozone. But here O3 does not mean it is ozone.
It means oxygen particles of
The
3 or
atoms of oxygen.
21 into 4, 124.
Ah.
42.
How much is it? No. Hydrogen plus nitrogen plus 3 atoms of oxygen. पूरा करना है ना? For nitric acid.
Hydrochloric acid. Ah.
62. 62.
I might see this. Hydrogen is 1. Nitrogen is how much?
14.
14. Oxygen is how much?
Oxygen 16.
16. 16 into how much you should do?
3.
So how much is this now? Come on, do it.
48.
62.
3 plus 48.
We are not the only children, not the child. So that's not. Okay, so everybody else knows. Silently.
93.
And 63. And 63.
62, 63.
62U. 62U.
And 63 U.
Plus 1. Plus 1 for hydrogen also.
63.
Yes, ma'am. One. There is only one molecule of hydrogen.
63.
62.
63.
See properly. How much is it? How much is this? This becomes 14,
28.
right? 14 and 1.
So 60.
That is 12. This is 13. Or carry. So this is 63U.
63 U.
Okay. So I'm not coming back again to this chapter because we have completed so many examples I have given. Now I'd like to see your notebook. Abhishek is showing your notebook whether everything is back. There you go. Which book is this now?
This is my SEGS.
Nitric acid.
See, this is the problem with you. You keep on changing something. Can I have your volume? Okay, in volume, I mark out certain things for you so you can complete it at home.
Nitric acid.
There are quite a few sums which are given here. I want everybody to do this. Suppose we have all that. And Avogadro number mole concept is not there. Okay, so that has been cancelled out. Now today we'll be starting a new topic, which is the next topic, structure of anatomy.
Mole is cancelled.
Yes, it's not there. It is not there.
Mole concept cancelled. Next step.
Okay, take a fresh page now.
Next step.
Has this topic started in any of the schools?
No, no.
So we have already like started the atoms and molecules.
Our listeners not know. How about having a test next time? Next week?
On atoms and molecules?
Yes.
Okay.
I'll ask only the formulas, nothing else. Only the formulas. Okay. Now I'll also ask you whether it is a bivalent, monovalent, polyatomic, positive, negative, all that we have to have.
Violent means.
Means we need to
By
load it.
yeah, basically
The table.
ions table you have to be careful. Are you following what I'm saying?
We have to learn.
You have a test, write it down.
Next week.
Next week I'll ask you, there's a test on formula, so you have to learn the tables on ions.
That's next Wednesday.
So now I'll be starting with structure of an atom. Okay? Take a fresh page, write down the topic name. So when we talk about an atom, it is something very small that we can't see. Okay? So how can we actually find out where the atom is? So for example, if I look at any object, does this have atom?
Yes.
Yes, it has. Yes. Because it has matter, and matter itself is composed of so many elements. Okay, so element itself is made up of atoms. So definitely we know that it is present around us, but it is so small that we are not able to see it. Okay, so many people like Dalton, okay, Thomson, they have put up certain theories which helps us to understand the structure of an atom. So the first part of the lesson, basically we are talking about how various theories were put up. Are you understanding? Okay. Various theories were put up, and some of them were rejected, some of them were still modified until we get better and better idea about what is the structure of an atom. Okay, shall I give you an example? Like for example, a computer, right? The computers that we are using now, was it the same 20 years ago? Definitely not. Okay, look at your very huge ones, as big as this room. Okay, then they started modifying, and now we are having a very sleek computer. Same thing with your mobile phones. If you look at the earlier mobile phones, have you seen it?
Now it was
Very nice. It was so big, bigger than this, and nice and fat. But now it has become smaller and sleeker, obviously because technology has really improved. Okay, so we know that the structure of an atom has gone through a number of steps, and right now what we are talking about the structure of an atom is something that has been refined and it has been accepted. Okay, so what is an atom? What does it contain of? So there are three particles which are present in an atom. What are those three particles? 8th standard we have already done something, so look at it.
Neon, proton, electron.
Yes, electrons. Okay, so electron, then we have a proton, and then we have a neutron.
Neutron.
Take it down, take it down.
Atomic number is what?
Okay, so any atom will contain electron, proton, and neutron. An electron is usually given by this symbol. It has E minus. E minus. That shows that an electron is negatively charged.
Okay.
Okay. A proton is given as P plus, shows that it is positively charged. And a neutron is usually given by N0 to show that it has no charges.
0.
Okay. Now an atom itself is what? It is neutral. What does it tell us? If the number of positive charges are 5, number of negative charges are also 5. So these two will always be the same, this and this. Okay? The number of positive and the number of negative charges will be the same in a neutral atom. In a neutral atom. Did you understand? So where are these present? So there has been a number of experiments that people have conducted, and of course now we know something about the structure of an atom. It consists of a central core. So this central core is what is known as a nucleus, and then we have these electrons which may be present in certain shells. These are what are known as orbit. Okay, so you have got the electrons which are present here. Maybe 2, 3, 5, whatever number. Here you have the protons and the neutrons.
That is nucleus.
That is the nucleus. So the central part of it is what is known as the nucleus. Take it down.
And this you to draw.
Yes, draw. Just a freehand you can draw. Draw freehand. So that is the nucleus. Okay. So protons are positively charged. The neutrons are neutral. These orbits are also called as shells. Shell.
Shell of a molecule, right?
Shell of a molecule. So this is a specific path. It's like a road. So these electrons are always moving around in circles. Okay. But now I want you to understand, is it a flat structure like this?
No,
Is this atom a flat structure? Is it a 2D structure?
not always.
Now is it?
It can be 3D, it can be.
It's not 2D. It is always 3D. It's like this. Did you understand? It's like a 3D structure, like a ball. Okay, like a
And
sphere.
then in papers, how is it, like, paper is like kind of thin.
It will be any small. Yes. Yes. This particular paper is made up of so many other substances, and the atom is so small that you can't even imagine that it can be present in the paper. But it is there, and it is a three-dimensional paper. So what is it? Suppose you are talking something like, imagine it is like a rubber ball. Okay, what is inside the rubber ball?
And
What is inside?
nucleus.
Nucleus.
And what is around it? What is
Orbit.
orbit? So these are the orbits. What is present in this orbit and shell?
The neutrons, protons and electrons.
No, I'm talking what is present in the shell. What is present in this outside shell?
Electrons.
Do you understand? Okay?
Uh,
Do you understand? So we have got the electrons which are present outside, and inside the nucleus what is present? There are two things. What are present? Protons and neutrons. Do you understand? Protons and neutrons are present inside the nucleus, whereas the electrons are present outside the nucleus. So this is also known as extranuclear. What is it called? What is it called? Extranuclear. That means it's present outside the nucleus. Do you understand? Come on, take it. I'll give you a few points for you to get on. Okay? The atom consists of atom consists of three particles. First one, electron. First point. You have written it, no, electron, which is negatively charged.
Then we wrote this.
Yeah, and always present in shells or orbits. Present in shells or orbits.
Negatively charged and present in
Shell or orbit. Second point. Where is second? What will you write about a proton?
proton and is a positively charged.
Particle. Where is it present?
Under
plus.
Where is it present?
The nucleus.
Inside the nucleus. Yes. Protons are present inside the nucleus.
Proton which is positively.
Yes, it's positive charge.
protons were present in
Then the number of electrons and neutrons affect the
And present in
Number of protons and the number of electrons will always be the same. Positive charge and negative charge will be the same.
and present in
I meant by asking if the number of electrons are more, will it affect the nucleus or not? Or number of protons are more, will it affect?
If the number of electrons will be more, the number of protons will increase automatically in the nucleus. Yeah, because the number of negative charges should be equal to the number of positive charges.
And then this and this, like what we learned in atoms and molecules.
Yes.
Why did the elements have positive and negative charges? Or
We are going back again to square one. We did not understand how we said it. Like for example, I said sodium. Okay. Atomic number is 11. You have forgotten, I think. Electronic configuration, what did we say? It is equal to 2, 8, 1.
2 plus 8 plus 8.
Not plus.
Ah,
It's a
yes.
comma. What does it tell us? What does it tell us?
Two
That
molecules.
is not molecules. First orbit, there are 2. Okay. In the next, how many are there? There are 8. 1, 2, 3, 4, 5, 6, 7, and 8. In the last orbit, how many are there? There is 1. So are these atoms? Are they atoms? What are we talking about? What are these?
ions?
These are the electrons. These are the electrons, not ions. Don't
Now,
get confused. Don't get confused.
we can even there is like a way to balance it also. Like if it is like above it is 8 and 1 and below it is 7, so we can give the 1 to 7 and it will be 8 and 8.
So no, not above and below. Don't use that word. So in the first orbit, you have got 2 electrons. In the second orbit, there are 8 electrons. In the last orbit, how many are there?
1 from
Sure. So what will you do with this 1 electron? What is the rule which did that? What rule did I tell you? That in order for an atom to be stable, it needs to have 8 electrons in the outermost atom. Okay? So it can either take 7 electrons to make it 8, or the other one is what? It will give away 1 electron. It will donate 1 electron. So this 1 electron is donated. So if this 1 electron is donated, Na becomes Na plus. So now it is an ion. Let me see. You got all muddled up again. Did you
I got
understand? Did you understand this one?
Yes, ma'am.
Okay. Why did it become plus? Because it has given away that 1 electron.
It has
What has happened to the number of protons? Now let us see. Protons, electrons, and neutrons. Okay. Neutrons are not changing at all. It is still remaining. Absolutely nothing. Originally, there were 11 protons and 11 electrons. But now it has given away. So how many protons, how many electrons and neutrons? Neutrons were not 1. Electrons, 1 is less. So how many will I write down? 10. What about protons? Will it change?
10.
Yes.
10.
Protons have not changed.
because 1
11.
Protons have not changed. Protons will remain the same. So there are 11 positive charges and 10 negative charges. So which charge is more?
positive.
1 positive charge. So that's why we put in 1 positive charge. Did you get it? Okay. This is what we had discussed in the previous chapter. Okay. So now we are talking in detail about how these electrons are present.
It's only to understand.
Is what I'm saying. Actually, they should have kept this chapter first and then they should have kept chapter number 3. That is a little, because we are learning about ions also. Understood till here? Okay?
When present in
What did you write? What is the last step? Present.
proton which is positively charged and
It is present. Where is it present? Proton. Because proton, where is it present? It's present inside the nucleus. It is present inside the nucleus. Is that okay? Neutrons are not taking part in any reaction. Okay, they are neutral. So it's always present inside the nucleus. Did you get it? Also, I want to tell you something about what is known as atomic number. What is an atomic number? Like, for example, sodium, I put it as En. What does it tell us? 11 number of ion.
9.
Yeah, number of
Yeah,
protons.
number of
11 charges. 11 charges
What? Of what?
of the
Electrons.
sodium. Sorry, 11 charges.
11 what?
11 positive charges of sodium and and 11 negative charges of sodium.
So we can say 11 protons or 11 electrons. But we usually don't talk about electrons because electrons can be given away, etc. So atomic number refers to the number of protons present in the nucleus. Is that okay? You people will remember about the test?
Yes.
Good. Okay. So I will expect you to get a paper or you get a paper from home. Write the test.
Thank you, ma'am. And happy Teachers Day.
Thank you.
Teaching was a good one.
Thank you. Do your homework. Read it properly and come to the previous one.
Once the statement is done,
Extreme.
but I edit it.
Let it come.